Welcome to a getting started with 3D printing talk. I wanted to go over a lot of the basics of what 3D printing is and how it works to prepare you guys for the incredible onslaught that is the 3D printer township, which you should definitely spend some time in over here. So before we get started, can people at the back here? Is it good? Excellent. How many of you have seen 3D printing before? Yeah, I'm looking to see if anybody hasn't, because it's probably impossible to leave the fair this year without seeing something. How many of you actually have 3D printers? Excellent.
It's still in the box though.
Oh no! I'm glad that you have a 3D printer. You should enjoy it. But this, so that's good because I gave one of the getting started 3D printer talks yesterday, and everybody not only had them, they were eager to talk about the more advanced stuff later in the process once you get really familiar with one. But this is a talk that will start at the very beginning and address what 3D printing is, and we're going to get through the highlights, and then I'll be able to field questions. Because I know you guys will probably have a lot of interesting applications questions for what you guys would like to do with these kind of tools. So the term additive manufacturing is the sort of official one that industry has chosen for what we more commonly call 3D printing, and this is sort of an interesting situation. 3D printing is actually 30 years old. A lot of people think it was just invented recently, and that it's a brand new science, but it's been around a very long time and has had specific roles in industry and with rapid prototyping for a while. And it's just now, basically since about 2007 and much more since 2010, that the idea of desktop 3D printing, of people having 3D printers in their home or access to 3D printing services to make inexpensive parts, has changed the behavior of how people use 3D printing and has really changed stuff. So even though the adoption of the term additive manufacturing came around that time to attempt to stop the use of the word 3D printing for this, they're entirely interchangeable at this point. But if you want to share your secret technical tips, you can say additive manufacturing from time to time. So a very simplified explanation for how this works, attempting to bridge the hundreds and hundreds of methods that machines are using to produce 3D printed projects. We have come up with any manufacturing process that builds a design up layer by layer. Layers are either extruded through a nozzle, like a precise computer-controlled glue gun, or cured by laser or projector. These are sort of the most popular modes of 3D printing, but you'll find new ways to approach this popping up every day. There's a really interesting story recently that I think it's either an engineering or design student used a robotic arm to go and selectively lay in parts in a big gel vat so that he could build structures with no support material, taking advantage of this 5-axis robotic arm. That's a pretty new way to build. It doesn't really match with the building up layer by layer. So watch for how this sort of develops as 3D printing gets more and more widespread. Did the video appear for you guys? Oh, can we go to the show? Aha. There we go. So the green print that's happening on I guess what would be your left, right? That's a print of a Yoda head that you will probably see all over. Very popular design to print. And one of the reasons that people print it is kind of a cheat. All the wrinkles of the skin are actually really good for 3D printing. They help hold things in and make a very pleasing final finish. It's actually harder to print really geometrically smooth, perfect sides. That shows off the limitations of the format much more. But you see, as we were going through there, how it was printing the outside, and then it was printing an infill that is a kind of grid pattern. That is so that you don't have to print solid material through the thing, but it maintains the shape and structural integrity to support the outer edges and also what comes up on top. So this is one of the things that you can choose typically with 3D printers when you're going from a design that you have ready to go to setting something up for a printer. You can choose how dense or solid you want the infill, and the slicing software will take your percentage of, I want it like 10% solid, or I want it 30% solid, and calculate a pattern that will make use of that much plastic and leave these chambers, so you reduce the print time and the weight of the final object, which is really great if you're say paying for the weight of the plastic, etc. And then on the other side is an example of a SLA print, and you'll see several more SLA printers this year than ever before. It is another process almost as old as FDM, FFF, the fused filament fabrication style that you have with the Yoda head. In fact, SLA actually precedes it. That was the very first mode, and you're using light to cure a resin and building the object up layer by layer, but it's actually lifting the object out of a vat of the resin material. It's really fun to see if you haven't seen that before. It's hasn't been featured as much lately because it's something that's just now becoming available for new people to create machines and materials to sell for these kinds of printers. Okay, well, so 3D printing's been around a long time, and it has had, like I was saying before, a very specific role in industry for rapid prototyping, stages of manufacturing, so that you can test something before you, say, go through the process of creating very expensive mold for injection molding, etc. Plays a pretty crucial role. But now that you have less expensive means of 3D printing and the availability of affordable 3D printers, now all this explosion of other things that you can do are appearing. For example, it's now affordable enough to make, toys and gifts for people and artwork that would otherwise have been prohibitively expensive. That industrial ring habitat, the huge ring with the sort of little smoke coming into the middle, is actually a tremendous object. And to 3D print it in the past or produce it in another manufacturing method would have been insanely expensive. So the artist just paid for it with his time and the plastic he needed to produce it, and that's it. It was over 200 hours of printing, but it was on his terms and with him tweaking every element as he was designing it. Like this big, it's really big. So people are still prototyping with these kinds of tools, but they're also using it for something sort of related to prototyping, but a little bit new. The automatic transmission, the red and black element up there, that is a working sort of teaching model of an automatic transmission. So it's not something you're going to throw into your car, but you can operate it, and it has the appropriate gear ratios to step between the various modes, and you use your finger to advance it from 1 to 2 to 3 gearings. And this is an example of how you can use a 3D printer to design and learn about something in the world that you're curious about, it's an incredible teaching tool and would have been really difficult to produce any other way. The Stirling engine in the middle is interesting not only because Stirling engines are fascinating, but somebody spent some time figuring out how to solve this and make something that would work, given that these sorts of plastics are pretty sensitive to heat. They're workable at a very low temperature, so you have to approach this a different sort of way. And he found a really great solution. It's a really interesting design. And which actually, I do want to talk about the plastics that are most commonly used in the FDM, in this style, the layering, building up of plastic that you'll see most frequently around here. People tend to use ABS and PLA, and ABS is the same plastic used for Lego blocks, though Legos are produced in a different method. They're pressure molded, but definitely, many of you should be very familiar with Legos and how light and strong they are and how much they hurt if you step on them in the darkness. It's a really great material to work with because you can make machines, you can make sculptural objects, and they're still light enough to work with, and the material is pretty affordable. So rather than, you're not actually precisely melting the stuff. You're really bringing up kind of like a viscous fluid to a workable temperature. So as a result, you're not really having the kind of state changes that you might expect from another like really industrial process. So they don't really off-gas. They're not dangerous. These are plastics chosen because they're pretty safe to work with, maybe right there where you design things instead of like out in a workshop or in an industrial space where you would typically work with much more dangerous toxic chemicals. And that has been a very big change for how people use these. They're right at hand, and people will sit there and iterate and design over and over right there where they're most comfortable, instead of sending off for their pieces to be produced and mailed back, and which can take a lot of time and money. And PLA, the other very common one, you actually are probably more familiar with it in terms of use because it's often used for cutlery and food containers. So it's been, both of these types of plastics have been around you all the time, and they're really convenient and affordable for working with. The resins, it's actually spending some time in 3D Printer Village will be very interesting in terms of learning of the resins for SLA, because there's so much development happening in how to make those more and more affordable and safer. A lot of the specific details are changing from week to week as people are discovering new ideas, new people are offering resins for you to work with. So in addition to creating things that are, say, mechanical models, etc., people are using these to design things, and maybe they're they're designing things that they want to use, not just to use as an example of what they later will want to produce in a different way. The atomic bomb mushroom cloud there is sort of an interesting model because it was created from taking footage of little atom bomb explosions and turned into a structural shape and then produced in a translucent material, so you can get a light source into it, light it up, and you have sort of suspended in space there that mushroom cloud from the video. The white watch body is an example of sort of a fun enclosure that, in this case, I made this one to go around an existing electronics project. I thought it would be fun to sort of change the shape of how this works. The kit, which is made by Additive, called the Times Square kit, which is really fun, is very square, and I wanted to see what it would be like to throw a very small enclosure on it to kind of round it out, make it more soft and organic. This year, more than the previous years, there's more and more things for you guys to explore here to learn about 3D scanning. There are many methods of 3D scanning, and I would say most of them are here somewhere. If not, I don't know that there are CT scanners, but there are examples of even some of the complicated medical scanners that are being used to source for designing all kinds of things, from scanning a mummy without unwrapping it so that you can see what it looks like without damaging the tissues. And I represent a couple of the most popular sort of maker modes for doing this. You can use a laser line scanner, and you'll see a lot of those this year. I mean, in particular, like the MakerBot digitizer over there, I think they have set up. And there's 123D Catch, which is a stereo photogrammetry tool. So you actually just use a normal camera, and you take photos from all around a figure and kick it into a cloud server that will then process it, find the sync points, and build the volume of the object you're looking at. Photogrammetry is actually as old as photography, but the stereo photogrammetry stuff, like the stuff I'm showing here, has only been available really for architects and for like sort of analysis using pretty expensive tools until recently. And I'm using 123D Catch in the picture along the riverfront to work with some people from the Milwaukee makerspace to try to 3D scan the bronze fawns, which is a local landmark of theirs. So you take photos all around it, any sort of camera you have, and upload it to a server. They give you a model back that you can work with. It's a really great way to work. Also, the Connect projects. You'll definitely probably see interesting Connect projects around. In particular, in the lower level, the Science Center, there's the Scanorama folks, which is a project from out in Coney Island to build a really handy sort of vertical rail system for using a Kinect that was designed for interacting with games as a 3D scanner. So they set it up so they can sort of run the scanner up and down and really efficiently capture all they need to make a 3D model of you and print it out. And Fred, who's running that process, is really fast. It's sort of neat seeing that, because these kind of processes, typically you would use a whole array of cameras and it would be very expensive, but his rig is totally affordable and much less expensive than the 3D printers that he uses. And one story that is particularly interesting this year, since January, there have been a number of projects that have popped up to address 3D printed prosthetics. And one of the reasons I really like highlighting this is that this is something that is now. It's not something like some of the exciting stories about 3D printing livers and all sorts of replacement possibilities in the the biosciences. This is something that's already in play and making a big difference in people's lives, and being produced in the cases of the children on the right on desktop 3D printers. So the prosthetic, a commercial prosthesis can cost upwards of $40,000, even $80,000, depending on what sort of situation you need, as far as you want it to behave as naturally, like give you the control to not think about it, not be distracted by what would be the best way to put that? There's a couple examples here actually on site. You can go see. There are ways that people have done things like sampling nerve firings further up the arm so they can still trigger the fingers, and you get really good at it, and you can have complete control over a hand, even if you no longer have that hand. These are being produced on 3D printers for children, and it's a very exciting development because they're able to track all the physical development of the kids and make sure that they always have these tools at hand, which is a very big difference in their lives. They're not always working with a slightly not well-fitting, shimmed sort of version of what they wanted to have. They can actually not only have them constantly updated and for only $100 perhaps in some cases they're reporting, but the kids can get involved with designing them and changing them and really kind of owning them, which is really just wonderful. So if I started to try to list out all the 3D printer options and vendors here, we'd be, through not just the next talk, but the one after it. There's so many options here. So I strongly suggest you travel around and take a look at what's here. And what you'll see is that not only the FFF, the fused filament fabrication ones that I was talking about before with like the green Yoda, etc., and the SLA stereolithography ones that are, pulling the object out of the vat that they're curing layer by layer, but there are actually a bunch of other modes of 3D printing represented all throughout the 3D printer village area here. So it's definitely worth spending some time there. And one of the reasons that there's so much interest in these areas and so many new printers appearing is that a lot of the key patents that had shaped, had sort of controlled the various modes that you could explore in 3D printing are expiring. And as they are, they're cycling into the public domain, and people are able to make machines and re-explore how these things work. So you're going to see more and more over the next couple of years of new ways to 3D print that haven't been available to be done on a affordable level. Sorry. And even if you don't have a 3D printer, there are a number of 3D printing services that are doing their best to make it affordable to print, not only using the materials I was talking about before, but a huge range of materials in machines that you really don't want to have in your home next to your desk. So you can take a look at things like Shapewaves, which is really, I think it's just right over there, and see all the various metals and ceramics that you can print using the same design files that you've been exploring to 3D print on a desktop 3D printer that you might have on your own. Proof a design and then print it in gold or silver and give it as a gift. It's a really neat way to go. So typically when people are first exploring desktop 3D printing, they'll spend a lot of their time going to places like Thingiverse, GrabCAD, and other sites and grabbing the incredible models that are appearing there shared for free for you to download every day. But after a while, you'll realize that they've been able to create something they're very excited about. I now want to create something I'm excited about. And this is a very good time to explore design because there are more and more tools and resources than ever before, a lot of them free. If you had any curiosity about any particular package or, way of working, you'll find thousands of videos on YouTube that will demonstrate how to do this. So there are a lot of people who, instead of going through a very long apprenticeship to learn how to use one tool that they will be sort of dedicated to for the rest of their lives, they'll pick up something here and there, and they'll watch a couple of videos, and they'll check out some training tools, and they'll be making things on the spot. And what's more exciting to me than even just all of these ways to get access to the existing tools that have been developing and getting better and better over time are all the new tools that are changing the user interface, thinking in terms of how you might want to design and trying to make it easier for you to go from your ideas into a design that you're ready to work with to print. So I'd strongly suggest you'll check out Tinkercad and 123D Design so you can see right in your browser some of the things available to you and try them out. One example of a place to start that we had selected when we put together this presentation, it's still when I talk to folks who are curious about 3D printing and 3D design, I ask how many of them have worked with 3D design software before, and there'll be some folks, and typically in the maker scene in particular, they'll have dabbled, they'll have tried some things, but they don't feel that they know how to express themselves with those tools as much as they would like to, and they're really eager to learn more. But you ask them if they've ever used Photoshop or Illustrator or tools to work in 2 dimensions, and they have tried so many things, and they're very comfortable, and they do it all the time. Well, that's actually a really good entry into working in 3D design. You can design elements in 2D and extrude them and stack them up, as you might think about Legos or a laser cutting project, and get some pretty interesting 3D forms that way. And as you get more familiar with how that's working, you'll start to identify the things that you wish you could do differently, and sort of add the tools as you need them to get the kind of shapes that you're really going for. After you've printed your object, there's still a lot more you can do. And while sanding might not sound like the most fun, these materials are really great to work with. You can do all kinds of surface treatments to create incredible results right from those bright plastics that you're printing with. And it really makes a difference when you can hand something to somebody that is, say, like with Cosmo's piece there, that bronze-looking horse head is a 3D printed object. It's tremendous. He has a background in architectural detail and exploring ways to get surface treatments onto items that would be on the edges of buildings and that kind of thing. So he's spent so much time looking into how things weather and change. And there is a lot of stuff out there to explore, so you can take those surfaces, change them, and produce a result that really feels like a different material. It's great for interacting with it and for giving it as a gift, and also using it as a proof of concept when you're trying to make something that would be extremely expensive to make and test. Let's see. And as you will see from 3D Printer Village, but also online reading news about where these things are going, there are more and more tools and for printing different materials and more printing materials that can be used in existing tools to allow you to try some really interesting things. And I was trying to check earlier, I think over in Maker Shed later today there's a talk by Matt Stultz about 3D printing materials. It's pretty fun because he's been testing how to use a typical off-the-shelf desktop 3D printer and a lot of the new feed filaments you can put into it to print in like nylon and wood materials and similar. But while there aren't that many things like this yet here, there are a lot of bioprinters being developed right now. And while you can read about a lot of really exciting things happening in research labs and that sort of thing, there's also a lot of these things sort of happening behind closed doors. I think we're about to hear soon about a lot of new things you can do with these kinds of tools. There are so many resources to learn about 3D printing here and through Make. I mean, spend some time walking through the shed to see all of the crazy options that they have, even just for accessories for 3D printers. And last year I helped put together the Ultimate Guide to 3D Printing Buyer's Guide with Gareth. And there's a new one this year that's coming out in November. And I got to participate again this year as well. And it was very exciting because so many of these printers have new models and new sort of tweaks for old models. They're printing better and better. Really, I won't give away too much by saying that there's just options now. I look forward to sharing that with you because you're going to get really excited about the new options you can choose when our reviews come out. And I'm really committed to trying to help people explore design and find ways to make the things that they want to make. So I'm working on a book, Design and Modeling for 3D Printing. And if you're curious about that, I'm actually going to give a little sneak preview, parts of it, at 12:30 right here. But thank you guys very much for coming.